Danny, over to you.
Okay, great. Thank you so much, Chris, and hello everyone. We will start on time today, as we did say we would keep this to about 20-25 minutes. So my name is Danny. I work as a consultant for ISO Energy, and we integrate multiple technology solutions throughout a variety of buildings in the UK. And today we're going to focus on more so the smaller scale domestic small commercial properties, leaning toward nearly zero energy and passive house buildings, and also looking a little bit beyond that, net zero plus the passive house standard and beyond is really where my personal passion is, and I hope your guys is as well. There'll be a little bit of a chat at the end as well if anyone would like to pop some questions in along as we go. But otherwise, I'm going to move relatively quickly through the slides, introduce myself, introduce ISO Energy, and review a few different things in regards to renewable technologies for passive house buildings. Yeah, so as I said, it's going to be a very short introduction today. This is the second series we've had. The first one went very well, and it was more so an introduction, getting to know people. Where are people finding they need support for renewable technologies? And then just keeping the language really, really simple. This can get very technical really quickly. We can get lost in spreadsheets and softwares, but I'm going to look at it from a really simple point of view, how we communicate as professionals, and communicating this to, of course, clients, and keeping it really simple. So yeah, a couple of points to go through today. I really want to focus on optimizing self-generation. I think this is the key at the moment, and this is where the incentivization lies. There are opportunities to support the grid, support the network, but right now we're incentivized to optimize the usage we generate on site and use it on site as well. So quick introduction to myself. I went through this briefly last time. I graduated a number of years ago as an energy engineer in Ireland and went straight into project management and delivery of old social housing stock, bringing very old properties up to B and A rated homes using predominantly building fabric upgrades, insulation, airtightness, and then at the very end putting in some renewable energy such as heat pumps. Found that I wanted a more practical overview of how it all worked, and became a builder as well. So I graduated in 2020 as a qualified builder in New Zealand, and in the midst of that built a small property myself from waste materials, which I'm also passionate about. And then I kind of combined all this together and found that personally I enjoy working in consultation of designing renewable energy systems, really looking at it from a practical point of view. How is it going to work on site? How is it going to be integrated? How is it going to be installed and maintained? So a little bit of an overview of myself. The building process is very, very important for me. And this is a property I worked on years ago, massive 400 square meter plus property. And just taking a look at all this underfloor heating pipe work that had to come from the other side of the world to here. And I thought, my goodness, surely there's a better way to do this. And in the midst of that, and before I found the Passive House standard, realized that we don't need this excessive pipe work. We don't need to construct buildings that need a huge heating or cooling demand, and that we can build a little bit more intelligently. So this was the result. It was a massive, massive property, but this needed two quite large air source heat pumps just to do the heating only. Whereas if it was designed, of course, to the Passive House standard, it would have only needed a portion of this. So all of that kind of led me to constructing my own little house, and I wanted to bring this in because it's important in terms of understanding the layers of design that need to go in, understanding how you can construct a building around what your end result will be. And it was important for me to get involved with an architect nice and early on as well, use their experience in the design and my building experience to construct. So short introduction to myself there, personally. And then quick one or two slides on ISO. We are quite a large company in the UK, founded in 06 and growing year on year. The predominant renewable technology in ISO is ground source heat pumps in old housing and estate housing, very large, very complex buildings. And then this excellence is really filtered down into the smaller scale domestic building, small commercial building that myself and some other colleagues are focusing on today. We keep it really, really simple in that we can be a whole house partner in terms of consultation, a design phase, completing the install, and then creating a relationship over time and maintenance and servicing of all the equipment. And firstly, consultation and design, especially on buildings that are working to hit numbers and targets, hitting, standards, of course, it's really, really important. So we like to really get involved at the early stage of design. We have multiple demonstrations of equipment at our offices as well as throughout the country with different clients who, we're happy to do small workshops on, brief catch-ups on what technology suits best, and of course get a feel for the size of these machines. Indirect heating systems and renewable energy systems do take up more space and are of a different scale. The consultation can look as complex as this picture shows on the left, or it can be really, really simple. And we can break down how much pipework is required, how much electrical cabling, measure in millimeters, literally the dimensions of the equipment that goes in, and work together on this. And then post-delivery, it's really important renewable energy systems are well maintained. And this, of course, is quite a large one on a small commercial setup that was installed. But it's important that it's delivered from the consultation all the way through to follow up for years to come. So fueling buildings, coming into it now, it's really kind of thinking about very simple principles of coming away from fossil fuel systems and using new renewable technologies. And I really like to keep the language simple when communicating this to everyone involved, in that we're just looking at it as fuel. We need to use fuel in, let's call it, a fire. And then, we need to also consider, how much storage, we're going to need to keep ourselves warm, keep ourselves having enough hot water and energy in our building. So looking at renewable technology as a fuel source, a fuel store, and the fire that gives us heating and hot water as it's done for thousands of years. So just a little bit of imagery here. I'm going to talk about the different technologies, but keeping simple principles in mind throughout this short presentation, I think is really key, and key in how we communicate to clients as well, and simplifying this. So what does it look like in passive house buildings and NZEBs, nearly zero energy buildings? It really doesn't start with technology at all. It starts with simple principles of design, the orientation. Solar gains are so important, for the heating of a building in itself. And also the shading, is key on overheating risk in the summertime, especially as the years go on. So we do have numbers to hit, but most importantly, it's done with the preliminary design of the building, the form factor, how the building is going to be used and what its purpose is, ultimately what the floor area versus the glazing area is going to be worked out and designed to. And then we add the fuel, and then we have numbers, thankfully, in the passive house standard that we need to go to and hit. The classic passive house really is something that's quite achievable and only needs a minimal amount of energy to give you heating and hot water. And then if you are to go a step above and beyond this and hit new targets, which many clients are aspiring to hit, you go for the Passive House Plus, Passive House Premium standard. And this is really where renewable energies are required on your PHPP calculators. We do need to know the quantity in kilowatt and kilowatt hours of renewable generation and how this is going to be used either in the home or sent back to the grid. And I'm really going to focus on how we use this in the home or the small commercial building now shortly. So again, simple simple communication is like follow the incentive. And right now, the incentive is to generate your own power, be it the roof of the building you construct, or if you're fortunate to have a field close by to the building or to the area the energy is required. And then you do need to consider a solar photovoltaic system. Unlike the solar thermal system, which works toward the hot water storage, solar photovoltaics will generate electricity to be used immediately in the building. And therefore, rather than sending the electricity to the home and then back into the connected national grid, we want to optimize this and use that generated electricity in the home through forms of a hot water power diverter, which you'll see there in the form of the iBoost, the very popular iBoost. And that device takes power directly from the solar panels and moves it into the immersion element on the hot water cylinder. And it's one of the most underrated pieces of technology available on the market. It's highly cost effective and highly effective in, essentially giving you free hot water for quite a large portion of the year. And then we can also assist with transportation and the challenges here, and we can look at electric vehicle charging points, such as below. Utilize this as a second form of self-generation and self-usage at the building, and then think about how we're going to use this in terms of supplementing a high hot water demand, potentially a higher heating demand. If we have too much self-generation, can we store this in what is the battery storage option? And also we have to think in passive house buildings, and pretty much all new buildings now require a mechanical ventilation heat recovery system. While the electrical draw is quite low, it is a constant, and it can be met with renewable energy sources. So what does this look like really? I mean, technically it breaks down into quite a detailed electrical drawing really. We are electrifying heat. We are creating a heat source and a hot water source for the majority, if not all, buildings. And it does break down into how much kilowatt requirement is needed in the building. Again, touching on the usage. Is there going to be multiple forms of energy source required? So heating for the home, hot water for the home and the users, but potentially there may be a swimming pool on site, for example, and it may need to be plugged into these renewable energy sources as well. So, there is a number of steps to go through electrically. Schematics need to be created, and it's very important that all of this technology communicates well together. But to simplify this in the next drawing and the next slide, I really, really like this visual because it's so simple to clearly see what's happening when we self-generate electricity. So looking at the PV array here, that is, of course, the fuel. The fuel is the solar PV, the solar energy coming into our system. And when it gets into the consumer unit here in the home, it then has the options of what we can do in optimizing self-generation. So first of all, you see another hot water power diverter here, plugged into a hot water cylinder and communicated with a clamp, sending signal back and telling the hot water power diverter when there is energy and fuel coming in and diverting it into the hot water cylinder. It's really a fantastic way in generating hot water in the home. That's a brilliant source of electrifying heat. And then, like I mentioned, secondly, we can look to assist transportation services, electric bicycles, electric cars in this particular image. It really is a simple process in that we generate fuel from the sun and we use it as close to the source of generation as possible. That's what we're being incentivized to do. Electricity, purchased from the national grid is getting more expensive over time. And right now the incentive is there to use this power on site. And should you then, after all of this self-generation, have surplus electricity, you can then divert it to a battery storage bank, or you can green the grid, which some people are really finding quite inspiring and really want to do, is green up the national grid through their generation. So coming on to like what the first piece of technology is in Passivhaus, you likely have seen mechanical ventilation before. Usually in the process of construction, you get to the point of post airtightness and you realize, right, what piece of technology do we need now to keep this Passivhaus full of fresh, clean, filtered air? And it is an MVHR system. So, you know, there's two types of ways we can do this. We can look to have an MVHR system that is solely focused on the heating. And if you add a cooling option, you can do heating and cooling from your MVHR system. Or on the right side of the screen here, you'll see the option to do all heating, cooling, and hot water from an integrated vessel. Now, this needs to be carefully sized. We need to ensure that the hot water demand is not going to be too high and too frequent for this product to be used in a Passivhaus building. So generally, the integrated solution of heating, cooling, and hot water works very well on a 1 or a 2 bedroom property where the usage is quite low. The frequency of hot water might be quite low as well. So the first piece of technology in starting with smaller buildings. And then really, if you're going a little bit above this, you know, you have to look at the fireplace. Essentially, what is the fire here again? Now it's the air source heat pump. In Passivhaus buildings and, you know, NZ buildings, actually the domestic hot water and the distribution of this can be the highest draw of energy in a home or a small commercial building, given that the building itself is designed to have such a low space heat demand. The hot water demand can actually be one of the highest points of energy usage. Thankfully, we have this fantastic, you know, trusted technology which can convert electricity. For every kilowatt of energy that you put in, you can get up to 3+ kilowatts energy out. So it's a fantastic way to meet this domestic hot water requirement and small space heating requirement in most buildings. This is quite a larger twin fan unit here. It looks like a 16 kilowatt system, which we rarely see in Passivhaus buildings unless it's a very, very large building. Or in my 4th point there, it could be for multiple dwellings, multiple units requiring hot water at any given time. They're super effective because, you know, they can meet the building regulations within a recognized budget. And then similarly, for the majority of the summertime, when they may not be required because you have electrical generation of PV, diverting that energy to your cylinder, you can look to optimize your air source heat pump in another source, such as an outdoor pool or an indoor pool close by. In terms of space, they're really, really effective in buildings for saving on space. You know, good design will include an air source heat pump pretty much back to back with the plant room, if possible, of the chosen building. And therefore, you have a really low piping and cabling routing. And it really does, you know, lead for a solid installation and simple installation as well to meet, you know, what you require for hot water on your PHPP calculator. And then look, it is really just about future-proofing the buildings, because in a couple of years' time, there's going to be no more gas and oil boilers on all new builds, and the predominant technology of choice will be the air source heat pump on properties. So how do you get the most out of this heat pump? You know, how do you get the most out of your fire? Essentially, you really have to optimize it. Like I've mentioned, there's a number of ways of doing this. I've spoke about the iBoost and the charging point. If you do have a potential pool nearby, or the building requirements have another high hot water requirement, a pool is a really nice way to divert and use this energy that you generate, put it into the fire, and then generate electricity to be used to do heating. Now, like I mentioned earlier, should you have too much self-generation, we can then look to battery storage. And battery storage, like you see in the bottom left here, can be stacked up in sequence, and you can really add a lot of kilowatt hours of backup power, and people really are kind of driven right now to be as close to off-grid as possible, or if they're constructing a new building, they want the Passivhaus standard. they're really leaning on actually being close to off-grid as possible, becoming very conscious of the energy usage in the home, and really enjoying how, you know, we can use this in an intelligent way, an intelligent manner. So there's a few other points we can talk about, such as like day and night rate tariffs. There's excess generation. These are probably points for another discussion. Considerations in the plant room is something, you know, again, early stage design, we want to really keep in mind indirect heating and hot water systems do take up space. Mechanical ventilation, heat recovery does take up space in a passive house. And these are just some, you know, very simple examples of how they need to be boxed in. Now there is quite a lot of space here in this example. It is a larger property, required a larger hot water and heating buffer tank. But we can look to design this in, again, a pragmatic manner, looking to optimize space, thinking about the indirect source of heating required, and knowing that we need internal space to do this. We have to site the equipment externally in the correct manner. You know, how far away from the plant room is an important one I mentioned previously, ideally as close as possible, but it's not always the case that this is possible. We need to have our plant room externally away from the building, which in rural areas can be quite popular. Proximity to your closest neighbour, you know, there are guidelines that we need to stick to for permitted development of this equipment. And adequate space around a heat pump is just an example of, we need to have enough space for airflow to ensure that these systems you know, live up to the efficiencies that they promise and that they deliver. But there is requirements specifically for different units which require airflow to one side of the other, and generally at the front and the rear. How are we going to get power to this system? Again, this is an all-electric solution. So we do need to think, how are we going to bring power from the building to the location of the air source heat pump? And enabling works, you know, do we need any potential enabling works to fit the renewable energy systems? Do we need to have space in a loft that needs to be boarded? Do we need to have a small concrete foundation outside for the air source heat pump to be located on? Where is the ducting going to go in the building is always a great discussion in early stage design. So, you know, really important to just consider locations of all of this equipment in the design process. Indoor plant. So here's a few more examples of projects we've done. You know, in that particular instance there, it really is a simple solution, a very small heat pump with an integrated unit. Actually looks quite like a fridge in this particular instance, and they are becoming more aesthetically pleasing. It's not like an old plant room in most cases where there's pipes everywhere, there's cables everywhere. The focus now is on, you know, ensuring that the equipment is compact, it's fitted well, it's fitted with not just the installation in mind, but also long-term servicing. There's a lot of moving parts in integrating renewable tech into houses. And we need to ensure that we can access many years to come a bit of a more involved plant room. And we like to see good design of a good plant room early on, ensuring that, you know, adequate space, there's enough room for pipe work and electrical supply to come through, and potential enabling works again might need to be done. Just thinking about the neighbours and proximity, you know, it's really important that we design with the sound of this equipment in mind. Now, air source heat pumps, for example, are getting quieter every design they come out with. Every new model, every year there's a quieter unit. But we do need to do a test, and a noise assessment does need to be complete, ensuring that we live up to the neighbouring properties. You know, for example, I'm doing a project in London at the moment, a very urban area with close proximity to both neighbours on either side. And it's important that we do a MCS noise assessment to ensure that the neighbouring windows will not be affected by the decibel level of the heat pump. So all completely manageable, just needs to be thought about again in the early stages. And then what's the motivation for, you know, both designers and clients and everyone involved in you know, building properties and building commercial buildings to these standards? We need to follow the legislation, of course. There's introduction, obviously, of SAP 10. You know, new regulations are coming through. Local planning conditions are a factor that change. You know, I know in Ireland many years ago there was a council in Dublin that integrated the Passivhaus standard for all new builds. And again, Scotland are the most recent large kind of country to, you know, target going for the Passivhaus standard from the outset. So renewables are going to be a factor in the design, and we need to future-proof the building to suit this. And potentially in the future, I would think as we evolve, there might be a carbon tax should you not follow the legislation, should you not integrate renewable energy sources from the outset in your construction. You're therefore creating a piece of construction that in time will be requiring more energy than it may have needed to do so, and therefore knocking on to running costs. So all of these things, I think, provide a solid base of ensuring we future-proof the building and you know, going completely renewable from the outset of its construction. Manufacturers are important. You know, we really do want to lead with, where we can, the best equipment available. There's a lot of equipment now on the market. Some are tried and tested. There's a lot of new equipment and new manufacturers, which is great. And we need to ensure that we, you know, make the right choices per project, per client. Some people like to have all the gizmos and gadgets that they can control these systems from their phone, from their computer, from any part of the world. Whereas in some cases, it's very simple to just have an on-off controller sitting in the kitchen, sitting on the wall, and keep this really simple. Enabling works, mentioned a little bit earlier. You know, sometimes there needs to be electrical upgrades to support renewable energy installs. On Passivhaus buildings, thankfully, the electrical draw is very low to begin with. NZEB is a very low draw. It's more so thinking about what is the purpose and the usage of the building going to be. Is there going to be a lot of solar potentially sent back to the grid from this building? You know, is there going to be a transportation requirement from this building? Multiple EV cars are likely going to be there in the coming years. Let's plan for them now. And I've already spoken about, you know, plant room preparation, a small concrete plinth. There's usually some form of enabling works to support a renewable energy whole house install. So yeah, a summary then, coming up toward the 130 mark. Like I said, the primary demand on Passivhaus buildings and nearly zero energy buildings is in the most case the hot water demand, especially as you go up into 3-bed plus housing. The likelihood is an air source heat pump needs to be used. You know, if you're in a 1 or a 2-bed or a multiple dwelling apartment complex, yes, you look to, you know, go all electric, use economy 7 night rate charging with just direct electric, but most cases now you do require an air source heat pump. And then looking to fuel this air source heat pump from generation in some part of the building or close by to the building. It may even be a community network solar installation, and it's really important if you want to offset minimal, if any, running costs over time. Technically going into the sizing of a system is really important, and this isn't just to suit the occupancy and hot water demand, but also technically we need to ensure the system volume of the whole distribution network is adequate for the renewable energy source. So that is a small buffer vessel may need to be added as a balancer to feeding, you know, electric underfloor heating, or excuse me, a wet underfloor heating or wet radiator system. Space is something I keep reiterating about. We do need to have a mini plant room to house all of this equipment. I really think it's great to have a bit of a workshop about this. It's often, you know, really good to sketch out over plans. You know, drawing on plans is a great way to ensure we allow enough space for the equipment required. Choosing manufacturers, you know, this is going to be something talked about more and more as a lot more people come into the UK now wanting to install. We have established renewable energy suppliers as well as new renewable energy manufacturers. Future-proof the home, decarbonisation in Passivhaus is a given. We're starting from a very low point, and why not go a little bit above and beyond and see, can we green up the national grid in putting a little bit more PV in where possible. Made a few points at the end. Just something I didn't really get into is the day and night rate tariffs, which is a big factor as well in capitalizing really on running renewable technologies or any technology. And then talking about excess generation to the grid. We're talking about the smart grid and how this is going to be optimized in years to come. It's a whole other discussion in itself. A massive utility provider are bringing in testing and collecting data. Every month a new test is being done. So this is really exciting and something to keep an eye on. And then, a lot of people, a lot of clients in particular are talking about, I want to green the grid. I want to send energy back. I want to over-generate and keep the grid green. And we are connected as people through our electricity grid. And it's a fantastic, resource for us as people. Maybe there needs to be an incentive, to fuel this. And happy to discuss that again, maybe on another lunchtime session. So kind of that's it. We're wrapping up now, just a minute or two past the half hour. I haven't seen any questions come in so far. If you have, Chris, do let me know. But otherwise, I just want to say thank you to everyone who's joined. It is early days in these webinars. It's the second one now. So if you do want to see anything else included, or any further, thoughts and questions, do get in contact, directly with me. Thank you.
Yeah, thanks, Danny. That was really, really good, really interesting. Yeah, so the chat was open. I haven't seen any questions come in, but you've got Danny's email address there, and you've got mine as well. So if you do have any questions at a later date, please come back to us. Yeah, Danny, you did actually freeze up on my screen for about 20 seconds at one point. I don't think it's going to make too much of a difference to the presentation, but I'm not sure if anyone else had that issue. What I will do is edit this and then put it onto a YouTube link, and I can email that out to everyone if they want to rewatch it or if they missed a bit at the beginning. So I'll send that out on an email in the coming week, just so everyone's got it. But yeah, I don't think there's any questions coming in. So I'd just like to say thank you very much for joining us today, and thank you, Danny. Really interesting. So yeah, if you have any questions, please feel free to send them afterwards. But otherwise, we'll say thank you very much and goodbye.
Okay. Thanks, Chris. Thanks, everybody.
Thanks, Danny. Cheers, everyone. Oh, here's one question coming in. One moment. What's this? Thank you. Very good presentation. Thank you, Jeremy. Very, very kind of you.
Thank you, Jeremy. Cheers.
Okay. Bye, everyone.
Thank you.
Cheers.